Imagine that this plate is a memory pool. Now I have an item, so I place it here. Then I get another item, I place it right behind that. Then I get another item, I place it behind the second one. So this is called queue. Every item will line up one behind another. You can imagine it like a queue standing to take the ticket from the ticket booth. And as soon as this person is done, it will move out. Then the second person will move out. And then the third person will move out. And so on. Each and every person will move out of the queue. This is called first in, first out. So the first person who got in is the first one who gets out. Hey there, and welcome back. So today we are going to implement dynamic queue data structure. This is a very important data structure and it has many applications. Queue in the simplest form is a simple linear collection of items which is placed one after the other. It orders in a fashion that whatever item comes first leaves the queue first. So it's first in, first out. There are many applications in computer science. Queue is used, for example, in print tasks. To queue the print task, you need a data structure to hold all the jobs. Queue can be used for a supermarket simulation. Queue is also used in trees and graphs for BFS, traversal, and many other things. I hope this video is going to be very informative and will set up the foundation for you to understand and build upon. So let's head back to the IDE and start coding. See you there. Alright, so this is where we left off last time. So I forgot to decrement the size in pop function. So now let's create another package. And it should be inside data structures, queues. And I'll create a class queue. Then I'll create a test class for this. This time I'm not going to create setup myself. I'm just going to select it from here. So IDE will generate it for me. In the setup, I want queue object, but queue of type integer. So we will change this one to match what we have here. And I'll create this field in the class. Queue, we'll set queue to null once we have run the test. It should push item to the queue and increment the size, because that is how we are going to assert it. So queue will have two operations. So yeah, so queue, we call it enqueue because we are going to push the item here, and our item is going to be 1. I'll copy it like we did in stack 3, 4, 5, and then we will look for the size. So this size should be equal to 5 because we have pushed or queued 5 items. I'll import this statically. Let's create this method. Here also enqueue is going to be a void method because we don't expect anything in return. Quickly adjust this. So first of all, we need to increment size. Once we have inserted it, I will quickly create this field in this class. Now, again, once the queue is empty, and how are we going to know that? If size is 0, then our queue is empty, and the first item is going to be our last item. We'll create a node. Now this node is going to be pretty similar to what we did in stack. What I'm going to do is I'm going to pull the node out of the stack package and put it inside data structures because this is common and we're going to use it. Now we will create a new node with and put this item there, and it should point to null. because this is the first node, and when the queue is empty, it is not going to point to any other node. So next is going to be null, and this is also going to be our last node. So I'll call it first because this is going to be the first always, and we can create a field for this first and increment the size. Great. Now we'll cover the second case where the queue is no longer empty and items are already there. In this scenario, we will have to maintain a current pointer as well, so that the new node can point to the current pointer and then it will become the current pointer. So here it will point to first and then current will be first. So I can create this variable as well. It will be same. Then I'll create new node with item and it will point to current. This is a new node. Then this will become the current node. Great. So this is how we are maintaining the pointers. Let's see if our test case pass or fails. We'll create a method real quick and return the size. I think this should work. Great. Now we can verify as well by creating another function, peek. It should peek the first item in the queue. Queue dot peek, and this should give us the item which is equal to, our last item will always be 1. So I'm just gonna copy and paste this here. And this will be of type T. Let's see if that is the case or not. Awesome. So this is pointing to the correct head. Now we need to pop or dequeue from the queue. From the queue. So instead of copying this multiple times, what we can do is we can put it inside the setup step. So every time we run a test case, this before each full block will run and it will initialize our queue for us. So we don't have to pollute our test cases with that data. Now I have to dequeue. This is going to be a void function. Yeah, now I can assert by saying that the expected item is going to be 2 because we will dequeue the first item, and our queue can give us this when we peek inside. And the size should also decrement by 1. This was the test case that we missed in the stack scenario. So here we won't miss it. So the actual size of the queue was 5 once we have enqueued all the items. Now when we dequeue one item, it will be 4. So queue.size should decrement by 1 whenever we dequeue. Create method. Now when we are trying to dequeue the item, what we want is we want to change the head for the first item to the second item. For this we can make a little adjustment here. So whenever we insert a node, we also want to keep track of the node after it. So as current node is going to be our new node is going to point to the current node, and our current node is going to point to this new node. Let's see if it works or not. So first will become first dot next, and size will be decremented by 1. Let's see if it works or not. It works. That's great. But let's try for more. So if we dequeue 4 items and we have 5, so the last item will be 5th. Let's assert on that. and the size will be 1, items will be 5. Awesome. So our queue is working as expected here. So what's next? So next we are going to create a linked list, and this will be a singly linked list in a linear fashion. Then we will code the doubly linked list. So I hope you will join me for the next video because this is getting excited. So see you in the next video. Bye bye.